See, this quiz here, this is all basic stuff. Tomorrow, okay, I made the quiz, I mean test. 10 problems, 6 points each. Okay, 6 points each. That means you get 43 points. But you gotta, some of you, you guys, I don't know if it was your class, but on problem 6b, you're not even using the correct identity for tangent 2x. You guys are using the tangent x over 2 identity. So like, if you use the wrong identity tomorrow, pretty much that's a fatal error. Anyway, 5 out of the 10 problems got hints on it. It's kind of sad, but that's what it takes. Okay, so we better, oh my gosh, look how many problems there are. We better get busy. See, you gotta clear up all the things about the quadrants and things, because like I told you, every sign that's wrong in the wrong quadrant, whatever, that's -2, and they're gonna add up. Okay, 1b. And in this class, you guys didn't even ask the important questions on trig B3 yesterday. Number 4a and b. You guys didn't ask that yesterday, but I think both of these will be seeing on tomorrow's test. But that must mean you got them all. Yeah. Okay, 1b. You have to be able to recognize identities, and you got to be able to work with them. And you got to recognize partial. Like yesterday's quiz. What was the second problem? 1b. Yeah, that looks like the double angle identity, but the 2 is missing. So what you got to do is put the 2 there and put a 1/2 on the outside. You got to be able to lomi. Okay, there's only one thing you can do here, right? Expand. Tangent of the first plus tangent of the second all over 1 minus tangent of the first, tangent of the second, minus tangent of the first minus tangent of the second, all over 1 plus tangent of the first, tangent of the second. Okay, you write that down tomorrow, you're 1 point. Okay, now tangent pi over 4, isn't that a number that we know? It rhymes with 1. 1. So you get 1 plus tangent x all over 1 minus tangent x minus 1 minus tangent x all over 1 plus tangent x. How many points do I get for that? Nothing! If you don't know tangent pi over 4 is 1, that's from the last test, right? You get nothing for that. Okay, now what do you do when you have to add or subtract fractions? Least common denominator, which is this times this, which is 1 minus tangent squared x, right? So on the top, you're going to get 1 plus tan x squared minus 1 minus tan x squared. So if you multiply out the top, you're going to have 1 plus 2 tan. It's all algebra, people. Once you use an identity, everything after that is just algebra. And that's the problem. All over 1 minus tangent squared x. So if you distributize that minus sign over here, the 1's cancel out, this cancels that, so you have 2 tan x plus 2 tan x, which is 4 tan x, all over 1 minus tangent squared x. And then you gotta go, hey, you somebody, huh? Yeah, the identity is a 2 there, but see, that's a 4. What are you going to do? Get flustered? Apparently. So what you got to do is you got to lomi. You want a 2 there. So if you want a 2 there, what? What do you have to do? You got to do this. Split up the 4 into 2 times 2. Because you need a 2. And then now that's the identity for tangent to x. And there you go. Simplify, it means to make simpler, because some of you are like hardifying it, and then it's going the wrong way. And then C. Cosine to the 4th pi over 12 minus sine to the 4th. Okay, well let me ask you this. When you took Algebra 1, and your teacher told you to factor this, what did you do? How do you factor that? Isn't that a difference of squares? Can't you factor that as x squared plus y squared times x squared minus y squared? Wait, let me look. Yes, that's what you do. I mean, pretty much, I guess that's not the only thing you can do. How many people did it like the bad way? The bad way is, okay, cosine pi over 12. Mr. Park taught us the math team secret. Cosine pi over 12 is what? Quick. Root 6 plus root 2 over 4. And then now I'm going to raise it to the 4th power. You guys even remember how to raise things to the 4th power using the binomial theorem? That's what I thought. Okay, so factor it. Okay, how do you factor this? It's a difference of squares. But see, if you don't, oh, and then, hey, you somebody. That's one. And then, hey, you somebody. Cosine of 2 theta. Well, what is 2 times pi over 12? Pi over 6, and then I know this number, root 3 over 2. So, yeah, there you go, that's the fastest way to do it. You have to, but in order to recognize identities, you have to know the identities. Because some of us still shaky on that. Okay. Okay, what do we got next? 3, 4. Man, if we had a lecture today, you'd be in trouble. Okay, number 3, I think we'll be seeing something like this tomorrow. Tan x equals 3/4. X is acute. What does that mean? First quadrant, right? So 3, 4, 5. And compute the tangent of 2.5x. Now, didn't we have 1.5x yesterday? So this one had 2.5x, so what do you think tomorrow? What, 3.5x? No! That would be too difficult for you. Go back to 1.5x. Or keep it at 2.5. Anyway, it's the same problem except different. How do you split up 2.5x so that you can actually do this problem? You want to go, okay, this is what some people said, 5x over 2. Well, in order to do that, then you better know the triple angle identity. Some of you barely even know the double angle identity, so how are you going to do that? So what do you do? What did we do with 1.5x yesterday? We went x plus x over 2, so what do you think we're going to do with 2.5x? 2x plus x over 2. You got to do things that you know. Do you know double angle identity? Yeah, just barely. What about half angle? Yeah, marginally. Anyway, once you split it up like this, expand. Tangent of the first plus tangent of the second, all over 1 minus tangent of the first, tangent of the second. I'll tell you right now, this problem's on the test. It's either 1.5, 2.5, or something else. I'll just tell you that. This one doesn't have a hint either. Okay, what's the identity for tangent 2x? 2 tan x over what? Why am I doing this? Now, there's 3 identities for tangent x over 2. Pick any one you want. I'd rather go with 1 minus cosine over sine. That's my favorite. All over 1 minus 2 tan x, all over 1 minus tangent squared x, times 1 minus cosine x over sine x. Okay, and now you just got to plug in numbers. What is, look at that, tangent x is 3/4, duh. 2 times 3/4, all over 1 minus 3/4 squared, plus 1 minus, now look at that picture, what is cosine x? So katoa, it's 4/5. What is sine x? 3/5. All over 1 minus 2 times 3/4, all over 1 minus 3/4 squared, times 1 minus 4/5 over 3/5. There you go. And I'll leave the computation to you. Yeah, but you know, it's easy because look, this and that are the same, and then this one and that one are the same, right? So whatever number you get there, just put it there. Whatever number you get there, put there, boom, comes up. Cinnamon oatmeal. 3, 4. Hey, can I use the same triangle for problem 4? What do you mean no? Yes! Tangent 3/4. It's the same triangle. Okay, sine 4x. What do I do with sine 4x? You want to go, well, there's lots of things you can do. You want to go 2x plus 2x? Or you want to do the more sophisticated 2 times 2x? Or the challenging 3x plus x? But in order to do 3x plus x, you got to know triple angle identities. Of course, the mathy people know, right? So, okay, I'll teach you the way that's going to benefit you on the test tomorrow. Because you got 2 times 2x. Okay, sine of 2 theta. What's the identity for sine 2 theta? 2 sine theta cosine theta. Theta is the 2x. Think of it as box. Sine 2 box is 2 sine box cosine box. Oh, when you say box, I can do it now. Well, whatever it takes. Okay, now, sine 2x right there. Hey, there's an identity for that. What is that? 2 sine x cosine x. And then cosine 2x. Get 3 identities. By now, everybody has their favorite. My favorite is cosine squared minus sine squared. If that's not your favorite, then don't use that one. Use the 2 cosine squared minus 1 or the 1 minus 2 sine squared. And then all you got to do now is just look at the triangle right here. So what do we got? 2 times 3/5 times 4/5. And then you got, what is cosine? 4/5 squared minus 3/5 squared. And then that's just computing numbers after that, right? You guys can handle that, I'm sure. You gotta be able to break down the identities. And that's 3, 4, 5. 5. Okay, now tomorrow, solving equations. I believe, I just made it this morning, I think there's 5 equations you gotta solve. So out of the 10 problems, you gotta solve 5 of them, you gotta just solve equations. And inequality. But I think 3 out of the 5 got a hint, which is kind of sad. Okay, we're doing 5C. What? Yeah, but Mr. Park, I saw the log and I got scared. Oh, speaking of scared, did you guys see the YouTube video they had? Was it in Brazil? The elevator. Okay, never mind. Okay, log. How do you solve log equations? Well, what you want to do is you want to combine this into just one logarithm. So if you have log something plus log something, what do you do with the arguments? You multiply them. Remember that from last chapter? Or 2 chapters ago? Well, you better remember. Remember, log of m times n is log m plus log n, right? Well, maybe that's why we can't do the problem. And then once you make a single log, how do I get rid of a log base 2? You 2 it. So if gorilla equal banana, then 2 to the gorilla equals 2 to the banana. 2 to the log base 2 of anaconda is anaconda. 2 to the sheep is lamb. Okay, now, you gotta get here now. Hey, use almost somebody. It's not quite. See, this is what you're gonna have to do tomorrow. It's almost somebody, but you gotta do something to it. To make this an identity, what do I need? You need a 2 in the front. So since this is an equation, multiply both sides by 2. See, 2 sine x cosine x, that's sine 2x, and that's 1/2. Hey, I know how to do this. Sine of what angle is 1/2? Pi over 6, 5 pi over 6. But since the variable, now this is going to come up a lot tomorrow. Now, I think like out of the 5 equations, 3 of them, you're going to have multiple angles, 3x, 4x, 5x. If it's 2x, you better go 2 times around. So add 2 pi to each of these. and then divide by 2. If it's 3x, you better go 3 times around. Tomorrow 5x, 5 times around. Because if you don't, it's -1 for each answer not there, right? So if it's like 3x and you don't go 3 times around, that's like at least 4 answers missing, right? I'm giving you hints, you know. Hope you guys are keeping track of this. Okay, D. Okay, now this problem is on tomorrow's test, except I'm going to give you a hint. I gave you a hint on trig B3, yeah? Yeah? Because usually the second time you see it, then you don't need the hint. Yeah, but Mr. Park, this is the first time. And that's the problem. Okay, but don't worry, tomorrow there'll be a hint on this problem. It's going to say change the left side of the equation to a product. And if you can't do it with that hint, then just do that. How do you change a sum into a product? What will you do? You use the, it rhymes with average. Average. What's the average of 3x and 1x? 2x. So you change this to 2x plus x, and you change that to 2x minus x. Okay, so expand each one. Now, for those of you who've been doing your homework, you probably don't, you can just go right to the answer, because you know 2 out of the 4 terms cancel out, right? What are you talking about? Cosine, cosine, minus sine, sine, plus cosine, cosine, plus sine, sine, equals cosine 2x. See? 2 out of the 4 terms are going to cancel out. That's how this thing works. And then you have iguana plus iguana is 2 iguana. Okay, now, how do I solve this equation? Cancel cosine 2x from both sides, losing 4 solutions in the process. No, you make one side 0. You never cancel a variable from both sides of the equation. Now, do you see why this works? Because now you can factor out the cosine 2x. And again, tomorrow, if it's not factoring, you're doing something wrong. Set each one equal to 0, so cosine 2x equals 0, or cosine x equals a half, and you guys can take it from there, right? That's like from last chapter. Don't forget to go 2 times around on this one, though. Okay, next. Oh, the log one. I erased it. The log one, I erased it. I forgot to check my answers. Because whenever you have a log equation, remember log gorilla. Gorilla always going to be positive, right? So I think some of those answers got to be crossed out. Okay, well, you guys go back to them. Plug it back into the original. If the argument is negative, you cross it out. What were the answers that I got? I forget already. Oh, no, I can remember. Pi over 12, 5 pi over 12, 13 pi over 12, 17 pi over 12. Am I correct? Okay, so pi over 12 and 5 pi over 12 are okay because that's first quadrant angles, right? But what was the next one? 13 pi over 12 is in the third quadrant, so you got to cross it out because sine and cosine in the third quadrant are negative. And the other one, 17 pi over 12, is in the third quadrant as well, so that's got to be crossed out. So the only answer should be pi over 12 and 5 pi over 12. Oh, okay, D, E, F. No! See, we did a problem just like this yesterday. No, why even, let's even point it out, we're not in the court of law, right? Tomorrow there will be a hint. Okay, this problem's on tomorrow. I don't know why I'm even telling you this. There's going to be a hint. Just like I put on, look, I put the hint on trig B3. I put the same problem on trig B4, all hell break loose. Okay, tomorrow there will be a hint. Let u equal 2x. U substitution. So what does this become? 2u, and that's sine u, and now we know how to do it. Okay, 3 identities for cosine 2u. Which one are you going to use here? The one with the sign. Since this side is sine, you want to make them all sine. It's quadratic, so you make one side 0. And it has to factor. If it doesn't factor, you're doing something wrong. 2 sine u. Sine u. 1 and 1 plus and minus. So sine u is equal to either 1/2 or -1. But remember, u was 2x. So you got to go 2 times around. Okay, so 2x equals sine of what angle is 1/2? Pi over 6, 5 pi over 6. And then when is sine -1? 3 pi over 2. But you got to go 2 times around, so add 2 pi to each of these. 13 pi, it's the same numbers as the other problem. 17 pi over 6, and then 7 pi over 2. And then divide everything by 2. So tomorrow, you know how I work already, right? You know how I think. So tomorrow, cosine 6x sine 3x. My hint will be u equals 3x. What's the only difference then? The only difference is that instead of 2x here, now you're going to have 3x. So the only difference is now you just go 3 times around. You guys can handle that, right? But now since I told you 6 and 3, now I got to go 8 and 4.
No.
But now that 8 and 4, now I got to go 10 and 5. Or I can go be tricky and go 7 and 3.5. Why? You cannot go 3.5 times around. Is that not legal? Whatever. And then F. I'm trying to help you here, people. Okay, F, inequality. Okay, the one problem will be an inequality, which means what? What does that mean, inequality? You gotta test the number line. That's what's gonna happen. Okay, the only thing you can do here is apply the identity there, which is 2 sine cosine minus 2 cosine squared. Okay, so make one side 0 and factor. What can I factor out? A 2 and a cosine. What's left? Sine minus cosine. Okay, once you factor it, you make the number line. What goes on the number line? Whatever makes each factor 0. So what makes this 0? Cosine of what angle is 0? Pi over 2, 3 pi over 2. What makes this one 0? When is sine equal to cosine? We did that one how many times? At pi over 4 and 5 pi over 4. Now we need to test. Now, can I just figure out the first one and just alternate? Yeah, you can, but you're playing with fire, you know. There is no pattern. No, it might alternate, but it might not. So you just have to pick a number in each region and keep plugging and see if it comes out positive or negative. So what's a good number here? 0. So if you plug in 0, this would be 1. And then 0 minus 1 is negative. So negative times positive times 2 is negative. But then if you plug in 0 and 2 pi, you should get the same result, right? So just alternate them, right? Playing with fire, people. So just pick a number, plug it in. I'm not going to do this. You guys got to practice. So easy to copy off the board. You got to practice. Can I just look at the bottom? Anyway, I can kind of, see if you have the sine waves in your bones, you know what I'm talking about. You can kind of tell that it's going to be like that for this problem. But we don't have it in our bones, so just plug in a number, man. How hard can that be? And then 6 and 8 and 11. Oh gosh. We're in a heap of trouble. X is acute, that means first quadrant. Okay. Now, there's only one thing you can do here. Is 24/7 a number I'm supposed to know for tangent? No, it's not. So you just use the identity. What's the identity for tangent 2x? 2 tan x all over 1 minus tangent squared x equals 24/7. What? You gotta do something. What do you want to do? Rhymes with Haas multiply. Cross multiply. Equals, actually, you know what we should have done? Is divide both sides by 2 to make the number smaller. But a lot of you not going to even see that. Yeah, so 2 all minus 12 tangent squared x. Hey, it's quadratic. Make one side 0 then. 12 tangent squared x plus 7 tangent x minus 12 equals 0. And what do you think? Do you think it's going to factor? So you got 4 tan x, we'll try that, 3, so 4 and 3, and then let's see, 4 and 3, 16 and 9, yes! So plus 16 minus 9 will give you plus 7, right? So setting each one equal to 0, tangent x equals either 3/4 or negative 4/3. Box that, that's the answer. No, you gotta cross this one out. How come? Because it says x is acute. That means it's in the first quadrant. When you take the tangent of a first quadrant angle, the answer is positive, so you cannot be negative, so you gotta cross that. See, that problem was kind of easy, huh? Okay, don't answer me. And then 8. No! The magic number! Don't worry, tomorrow it's going to say, hint, use the magic number. So sad. Okay, I will do either A or B in the interest of time, because otherwise we're not going to even get to 11, and then you're in deep trouble. Okay, A or B, which one is sine or cosine? Are you sure? Because that's the easy one. Why did you pick A? Because you said not to pick B. Okay, first of all, what's the magic number? It's the square root of A squared plus B squared. So the square root of 3 plus 9 is square root of 12, 2 root 3. So what do you do with the magic number? You factor it out. What's left? 1/2 sine x minus root 3 over 2 cosine x. If you haven't figured it out by now, people, one of them is going to be 1/2, the other one's going to be root 3 over 2, right? Okay, whatever. Okay, now we want to write a sine function. So what's the identity for sine? Sine, cosine, cosine, sine. Now look, we already have the sine here. Had a couple people in another class came in and didn't. Look, the sine is there already, so you have to change this one to cosine. Cosine of what will give me 1/2? Pi over 3. Then this is the cosine, then you got to change that one to sine again. Sine of what will give you root 3 over 2? Pi over 3. Hey, you somebody! That's the identity for sine of x minus pi over 3. And that's it. See, and the variable got to be first though. Okay, that was strange. I thought we were experts at magic number by now. And then finally the last one. Oh my gosh, we only got 4.5 minutes. We're in a heap of trouble. Hopefully we can do it. How many people got this proof? That is it. You guys are not sitting there. And you got to keep working it out. You guys, I don't know what you guys are doing. Okay, you got to work with left side, right side, or both. You got to start somewhere. Okay, first of all, how many times have we seen 3x over 2? That's like 1.5x. What do you do automatic tomorrow? If you see 1.5x, what are you going to do? How are you going to split that up? X plus x over 2. Oh, then I can use identity. Tangent of the first plus tangent of the second, all over 1 minus tangent of the first, tangent of the second. And then since everything on that side is sines and cosines, probably you want to change everything to sine and cosine here, right? So let's do it quickly. So sine over cosine is tangent. Now, tangent x over 2, there's 3 identities. Which one do you want to use here? Which one is the best one I told you? 1 minus cosine over sine. You don't even think that's the best one to use. Times 1 minus cosine over sine. Now it's starting to take shape. What do I do now? How do I simplify when you have a complex fraction? Multiply top and bottom by the LCD, which is what? Sine x times cosine x. So multiply this by sine x cosine x and you get sine squared. Multiply this by sine x cosine x and then you get cosine x minus cosine squared. Ooh, you somebody. Look, there's somebody. Okay, multiply this by sine, cosine, so sine x, cosine x. And then when you multiply this thing by sine x, cosine x, they cancel out, so you get sine x plus sine x, cosine x. Okay, and then look, hey, this and that, you somebody, what is that? That's cosine 2x plus cosine x. And then, what is sine x, cosine x plus sine x, cosine x? That's 2 sine x, cosine x. You somebody! Sine 2x minus sine x. Left side equal right side. Quite easily done. What? Well, yeah, you somebody! Because this one you gotta factor out the negative. See? Quite easily done! Yeah, it would help if I looked at that, yeah. Okay, the bell's gonna ring already. You have to have those identities at your fingertips. You have to. I mean, if you're just struggling trying to remember them, then you're in a heap of trouble already. Okay, Chen, I gotta pass back your papers. Chen.